Everyone, welcome. We'll just wait for a couple of minutes to let everyone join. Welcome. In the meanwhile, I'll have my screen up. All right. Welcome, everyone. We'll just get started. So, welcome to the session on Introduction to Docker 101. So, I'll start with the complete fundamentals, even if you're not familiar with containers or orchestration, all of that. So, I'll start with the fundamentals. A little bit about me before we begin. So I work as a DevOps engineer at Deloitte, and I've been involved in quite a few hackathons in different roles. I've organized hackathons. I graduated in the previous year, so I've been involved in hackathons in different roles, and I also love being part of different tech communities. So you'll find me in various communities in different roles there as well, and I'm also an Angel Hack ambassador. So this is a little bit about me. I don't believe this is updated, but yeah, that is a little bit about me. And let's talk about today's agenda. So let's look at what are containers and what problems do they solve, and how does Docker work fundamentally. So the basics of Docker, and then some basic Docker commands that you will require as a developer. So I'll focus this talk on how you can use Docker as a developer, and we'll go over some hands-on with Play with Docker. So Play with Docker is a SaaS product, or not really a product. It is a SaaS offering where you can run Docker commands in the cloud without having to install Docker on your machine. So really cool website. And we'll also look at a real world example of using Docker. Uh, all right. So let's look at containers first. So before we look at containers, we'll need to understand what are virtual machines and how it compares to a container. Just to set the fundamentals right. So a virtual machine is where it is a software that emulates an actual computer system. So you have an actual computer on an hardware installed on a hardware, and you can have multiple virtual machines installed on top of those uh, actual computer system. So those are virtual machines, and all of these are enabled using a technology called hypervisor. So it is a layer that sits on top of the actual infrastructure and enables to create virtual machines. So each virtual machine is isolated. If you look at the diagram, each has its own complete guest operating system, and then has applications installed in it. So these are heavier compared to a container. So that is where containers come in. So each of these virtual machine has its own complete operating system on top of it. So these are actual complete computer systems, but in a virtualized fashion. So what are containers? So you can think of containers as anything that holds goods together. So for example, you can think of it as a shipping container, where you would put everything that you want to ship from one location to another, and then put it on a ship, and then it would be uh, shipped from one place to another. So that's the exact analogy of a software container. So you put everything that your application requires, or everything that your software requires to run inside a container, and then you ship it anywhere, and then it can be run anywhere. So that's the fundamental idea behind a container. So if you notice the diagram over here, there is no hypervisor involved over here. There's just the infrastructure and then the host operating system and then the Docker that lies on top of it. And you can have multiple applications, the containers applications running on top of Docker. So you don't really require a complete guest operating system for each application that you're running. And all of these are once again isolated. So you get the same kind of advantages with virtual machines, but in a lot lightweight fashion. But there are obviously a lot of other differences that when it comes to virtual machines and containers, each have their own use cases. But lately, we've seen a lot of adoption of containers since because of its lightweight fashion and a lot of other reasons. So why should we care about containers? So these are the reasons why containers are being rapidly adopted. So you build ones and run anywhere. So we look at this when we create our own Docker images and containers. You create an image once, and then that image can be shipped anywhere and then run anywhere where the Docker environment is available. So it's a clean, safe, portable environment for the application. That is, you package only what is necessary for the application, and then it is portable. That is, you can ship it anywhere. So it's clean and safe. You only package what is necessary and not everything that is present on your machine. And the main positive point about containers is that it eliminates the worries about missing dependencies. For example, you're working on an application that uses an X version of a library, and you also have another application that you're working on that uses the Y version of the library. So if you're installing both of them on the same machine, there'll be a difference or a clash among them, and you'll run into some issues when doing that while running it in that fashion. So when you containerize your application, everything is isolated in it, and it has the right dependencies defined to it, so that each container is independent from the other container. So that's the main thing that Docker solves or container solves. And each application runs in its own isolated container. So that is the point that I mentioned, that you can have multiple versions of the libraries in each application, or each application can have its own version of the library without having any conflicts with the other application. And you can automate testing, integration, and packaging. That is, during your release, you can quickly spin up containers, do some testing on it, and do some integration testing on it, or package it as an application, or package it as a container, and then release it. All of these can be done very quickly using containers. Traditionally, you'll have to start up your application, or if it is a virtual machine based application, you have to create an entire virtual machine and then test on it, destroy it. All of that overhead is removed using containers. So it is technically a virtual machine without the overhead of a virtual machine. That is, it does not come with its own guest operating system, so it's a lot lightweight. So just to set some context about containers, obviously there will be a lot of hands-on as we go forward. This is just some theory, just to get the fundamentals right. So that was about containers. So where does Docker come into the picture, right? Obviously, containers does not mean Docker. Docker is just one of the tools that enables us to use the container technology. So Docker Docker actually mainstreamed containers back in 2014. Earlier, there were concepts of containers, the Linux containers, but there was no way to ship an image. So what an image is it's an persistent snapshot of an application. So you take everything that you require for your application and then package it as a image instance. That capability was introduced by Docker. Earlier, there was no way to ship your application as an image from one instance to another. So once Docker introduced that, containers became really popular, and then it took off from there. So images that persistent snapshot of the application that can be run. So what do we mean by running an image? So when you run an image, you get multiple containers that you can spin out of it. So when you run an image once, you get one container, and then similarly, you can have multiple containers running off the same image. So if you're familiar with object-oriented programming, you can think of this something like an image as a class and a container as an object. So you can have multiple objects created of the same class, right? So image is like a blueprint that you can think of an image as a blueprint. So that Using that blueprint, you can have multiple applications running. So multiple instances of the application running, multiple containers. So that's about imaging container. What is a Docker file? So a Docker file is a simple text document that has a list of commands to build a Docker image. So it has no file extensions generally, but you can name it anything. And then there are ways to provide that file name to the Docker. But usually it's named Docker file with a capital D. And then Docker automatically knows that this is the Docker file, or this is the list of instructions that I need to use to build the Docker image. So for example, if you have a node-based application, the first instruction would be to define the base image. So each image has a base image. So each image is built on top of an existing image. So the first base image would be to say, define the node environment. So you define what the kind of node environment that you want, node, and then the version of the node. And then copy the source code. Next step would be to copy the source code. And the next instruction would be to install the dependencies. And then finally, you would run the application. So this is how you define all of these instructions in a Docker file. And usually, generally, developers are involved in writing the Docker file. So that's something developers who work with the Docker environment need to learn. And the Docker client is a simple CLI utility, or it can be anything for that matter. There are APIs exposed as well, but generally it is the CLI tool, the Docker CLI tool that runs the Docker commands. For example, you can run Docker run, Docker PS, Docker build. These are some of the Docker commands. We'll look into these individually as we go through. So the Docker client is just a client that interacts with the Docker daemon. So the Docker daemon is the actual server, or there's an HTTP server that is running the engine. So that makes calls to the kernels to create and operate and manage the containers. So there's a Linux concept called namespaces. All of that is handled by the Docker daemon or the engine. And the Docker registry is once you create your own image, you can push those images to a remote registry, and anyone, your friend or anyone who wants to use that image can pull it from that registry. So that's a Docker registry. There's also a local registry, that is where all your local images would reside. But when you talk about registry, it's usually people refer to the remote registry. So that's where a centralized place in the cloud where all your images are stored. So the most popular one, or the default one, is Docker Hub. I'll just quickly go over the Docker architecture as well. This is just on a high overview. So there's the client over here that communicates with the Docker daemon. And the client can be either a remote API or just the CLI tool. And it communicates with the daemon, which is on the host. The host can be any machine. So it can be, Docker can be running on your machine, or it can be running in the cloud, it can be anywhere. So wherever the Docker daemon is installed, that is the host. And it communicates with the Docker daemon, and it creates images. And those images are run as containers. And the registry is something that resides outside somewhere in the cloud where you can pull images. So there's actually a color code over here. That is the purple one. If you follow the purple one, when the client issues a build command, it is actually to build an image. So it'll issue a build command to the daemon. And if you follow the purple line, it builds the images. And the yellow or the orange one is to pull the images. So when the client issues a pull request to the daemon, it goes ahead and pulls the images from the hub. So it is the Docker hub that we're referring over here from the registry. It pulls the images and stores it locally on the host. And when we issue the run command, that is in the green color, when the client issues the run command to the Docker daemon, it goes ahead and converts these images to containers. So it can have multiple containers of the same image. So that's where I mentioned the correlation between just the objects and classes in object-oriented programming. We'll also go over the Docker lifecycle. So if you're familiar with the Linux process lifecycle, it's very similar. You can create a container. This is the container lifecycle. So not just limited to Docker. There are similar tools like Docker out there, but the most popular one is Docker, of course. So when you create a container, it's in a created state, and then when you start a container, it's in a running state. You can pause a container as well. Similarly, you can stop and unstop. Once you stop, you can delete it. You can also delete it when it's in a created state as well. but you cannot delete a container directly when it's running. You need to stop it first and then delete it. So this is just on an overview. Just wanted to cover that. But the main focus over here is to cover the actual Docker commands, and then how you can run applications as a Docker, how you can Dockerize applications and run them using Docker. So we've covered some of the Docker important terminology. Let's go over to hands-on with PWD. So PWD here stands for Play with Docker. So if you go to Play with Docker, just search for Play with Docker on Google, and the first link that we find is labs.playwithdocker.com. You will need to log in. I believe I've already logged in. You'll need to log in using your account from hub.docker.com. It's a free account. This is the registry that I was referring to, the Docker Hub. Just sign up, get an account, and then using that account, you just log in to labs.playwithdocker.com. You can obviously install Docker on your machine, but I will not cover that because it will depend on. Okay, looks like some issue with Play with Docker, but it's usually not the case. You can go ahead and use Play with Docker to as a remote environment to run Docker commands. But you'll get a terminal in the browser, so you can run Docker commands over there. Unfortunately, there's some issue with Play with Docker right now, but just go ahead and create an account with hub.docker.com and then log in through Play with Docker. So I will be running all the commands locally on my machine since I have Docker installed. The reason why I'm not going over installation of Docker is that it will depend on the operating system that you're using. And there's also a product called Docker Desktop. So I suggest you install Docker Desktop. The reason is that it comes with a GUI and it's a lot easier to install, and it is free for educational and academic or personal use. So the reason I don't have Docker Hub is because it is a little high on storage. So I really don't want to waste my storage on Docker Desktop, and I am capable of using the Docker CLI. It comes with an excellent Docker GUI. So go ahead and install Docker Desktop. So I'll actually show you the Docker Desktop. Search for Docker Desktop. You can install Docker Desktop based on your operating system. You'll be able to find that through Google. Right. So we're getting into hands-on. For some reason, Play with Docker is having issues. Otherwise, you could have followed along, or if you already have Docker installed on your machine, go ahead and use that. Or there's actually another option, Gitpod, but I'll not cover that. If you're familiar with Gitpod, go ahead and create your Gitpod workspace. It comes with Docker. All right. Okay, do many hosting applications use Docker in order to host? Yes. So yes, there are a lot of applications. There was a comment in the chat. Do many hosting applications use Docker in order to host your app, especially backends? Yes. So a lot of applications use Docker to host containers, and generally it's not just using Docker alone. There are other orchestrators that you'd use. For example, a lot of applications are microservice based applications. That is, you have multiple services in the same application. So each service is a separate container, is its own container, and you would need to orchestrate them. That is, you need to make sure all of them communicate with each other, all of them are healthy, all of that functionality is taken care by an orchestrator. So there are the most popular one being Kubernetes, but there are Docker, there is Docker Swarm. The simplest one is Docker Compose. So that's how you would run Docker containers in a real world scenario where you have production applications. You would use a container orchestrator. But for this workshop, I'll show you how you can run individual containers. So where you individual containers are also definitely a real world use case. For example, you're working on your application and you need to containerize your application and then make sure you can use that locally. All of that when you're using a single application, a single container is obviously a real world use case. And yeah, to answer that comment regarding especially backends, yes, not just backends, even front end is also hosted on Docker in containers nowadays. So almost everything is hosted on containers. Even IoT based applications is on a container. So let's continue with the Docker commands. All right. Let's continue with the Docker commands. The first one we look at is Docker pull. So this is used to pull images from the remote registry. So let's go ahead and execute that. I'll zoom in a little. Okay. So Docker pull. Please excuse my mechanical keyboard. Sorry about that. So Docker pull, and then we'll pull an image called Hello World. So this is a dummy image that the folks at Docker have created, just to just for folks who are getting started with Docker. And when we issue this command Docker pull, it will go ahead and pull from Docker Hub. But there are other registries as well. By default, it will pull from Docker Hub. You can specify the registry, while pulling the image, like Docker pull the registry name / and then the actual image name. But we'll work with the default Docker Hub. All right. So it's using a tag default. So each image has a tag associated with it. So that's how you would version your images. So when you have a new version of your application, you would put that version as a tag and then release that application. So by default, when pulling or referencing to an image, if you don't provide the tag, Docker will use the latest tag. So that will pull the latest image or use the latest image. So it is pulling Hello World image, and then it has pulled the Hello World image. Let's go ahead and verify that using the Docker image ls, or you can also use Docker images as well. It's the same thing, but the Docker image ls is the newer version of the command. So if you notice that it mentions the repository, that is the image name, the tag, that is, we did not specify any tag, so it is using the latest tag, and each image has its own unique ID. So you can use this ID to reference to the image. If you're using any kind of automation, you can use this image ID and some metadata about it, that is when it was created and the size of it. So this is how you can pull images from Docker Hub. But generally, you don't need to explicitly pull images from Docker Hub. For example, if you're trying to run an image as a container, if Docker is not able to find that image locally, it will automatically go ahead and pull that image. So you don't generally use the Docker pull command a lot, but that is one of the commands that are provided. So the next one is Docker images that we just went through. It will display all the images it present in the local machine. So in my machine, I just had the one image that I just pulled. So it is just showing me that. But if you had more, it'll obviously show you all the list of images that you have locally. And the next command is Docker RMI. It is used to remove a Docker image from the local machine. And obviously, when a container is running using that particular image, you cannot remove that image. You'll need to first stop the container, remove the container, and then you'll be able to remove the image. But you can forcefully remove that image while it is still being used by a container. Definitely not recommended, because obviously it'll run into issues when the container is not able to find the image because you've removed it. So that's not definitely not recommended. All right. So we'll go ahead and remove this image. So there's two ways of doing it once again. For a lot of these commands, there are two ways of doing it, because Docker recently, or not really recently, but changed the way all these commands are used. So there is Docker image rm, and then the image ID or the image name. I'll use the image ID. So you can also use Docker RMI and then do that, but I'll use the latest style of doing it. That is Docker image, and then followed by the verb or what we want to do, ls, rm. So these are very similar to the Linux commands. So I'll clear my screen now. And if you look at the list of all images, there's nothing, because we deleted the only image that we had. All right, let's move on to the next one. So either the image name or the tag can be used. I use the tag, but in this example on the screen, I've used the name. So it will do the same functionality. The next one is Docker run. So this is one of the most important commands. So this is how you would run an image as a container. So image by itself only has the application code in it, and maybe it has all the dependencies installed in it or whatnot, but it is not the actual application running in an image. Only when you run the image as a container, you have the actual application, so you can interact with the application. So the actual application is brought up using the Docker run command. So let's run a Docker container using Docker run, and then we'll run the hello world container itself. So hello world image, sorry. So we're specifying the image name after the Docker run command. You can also specify the tag, that is after colon, and then provide any tag. If you don't provide any tag, like I mentioned, Docker will go ahead and use the latest tag. So we've also deleted this image from our host machine, right? So now if we enter this, it is unable to find the latest image locally. So it will go ahead and pull that. So that's the reason I mentioned you don't need to explicitly pull images each time. Right. So the pull was successful, and then this is the output from the image. So this is, like I mentioned, this is a dummy image created by Docker team. So the only purpose of this application is to print out this message. So if you have an actual application or a node based application, it would actually bring up that server, or if you have a database, it will actually bring up the database server. But this is a very dummy image. The only purpose is to print out this message, and it has done that. So like I mentioned, this is for folks who are getting started with Docker. It'll just print some image of some message. All right, let me clear this. So this is how you can run the image as a container. So now if we look at Docker PS, it should be nothing. Yeah, Docker PS and -a. So we are providing the all flag. So this will provide us a list of all containers irrespective of their status. So when we run Docker PS, it will only provide us the containers that are currently running. Docker PS-a will provide us list of all containers irrespective of the status. If you notice the status here, it says exited 54 seconds ago. The reason why it exited is because the container completed its purpose and then it had nothing else to do, so it exited. If you have a server, it will obviously be running forever, so it will not exit unless you explicitly ask it to exit, or it ran into some issue and it exited. So let's look at the output of Docker PS here. It has the container ID. Once again, each container has its own unique ID. You can use that to refer. And the image that it is referring, we are using the hello world image and command. So each image has a command associated with it. So that command specifies the image, what should be run when it is run as a container. So for example, if you have a node-based application, I'm referring to node-based a lot because I think that might be one of the popular frameworks or applications out there. So if you have a node-based application, the command over here would be npm start. So when you run that node-based image, the npm start command is run, and then the container will have that server running. If you have, say, what other example, Python based, you can have Python and then name of the file. So that's where what the purpose of the image is specified in the command. So we look at how we can specify this. But here it is calling /hello file. But let's just ignore it if you're not familiar with what this /hello is. It's an internal command that is being called by that image. And it has some more metadata about when it was created, the status of it, and ports is when if you expose a port from the container to the host, or any of the port data is specified over here, and it has a name associated with it. By default, Docker associates a random name to it. You can also specify the name while running a container. We'll look into that. So these are some of the Docker run flags. So the -d flag indicates the run the container in a detached mode. That is, it will run the container in the background. For example, you have a server, an Nginx server, or any kind of server. You want that server to be running in the background, because if you run it without that detached file, it will take up your entire terminal, and when you close the terminal, the server will die, or it will be killed. So that's the reason you want it to be running in the background. You'd use the -d flag. We'll look at an example for this. Not an issue. And the -i flag indicates an interactive mode. That is, if you want to run a container in interactive mode. So each container, is kind of a VM, like I mentioned. So it has its own shell inside of it. It has a kind of an operating system, not exactly an operating system, but it emulates an operating system. So you can have Ubuntu or CentOS, any kind of operating system running inside a container. So you can interact with that container using the -i flag, And then -t flag attaches a sudo tty, that is, it attaches a terminal or a shell to the container while it is running. And then the --name flag is used to specify the container name. If you don't provide any name, it will generate a random name. If you want to provide an explicit name, you can use that using --name flag. And then -p or the --port flag is used to specify the port mapping. So for example, if you have a container that is running on port 3000 inside the container, and you want to use it on port 3000 outside the container on the host. So by default, you cannot access any port that is running inside the container. So that is how containers are completely isolated. So there's no sharing of anything between the container and the host. That's how it's secure and portable. So if you want to use that port that is running inside the container, you need to expose that port and then map it to a port on the host. So you can do that using the -p or the --port command. And finally, let's run a Docker Ubuntu container. So it's not exactly a complete Ubuntu container. It's only emulating Ubuntu container using some of the Linux functionalities. So if I run docker run -it Ubuntu, so this will run an Ubuntu container in an interactive mode with a sudo terminal attached to it. So like I don't have the Ubuntu image in my machine, so it is pulling the image from Docker Hub. Let's just give it a couple of seconds for it to pull the image. This will once again depend on your computer's bandwidth. All right, so we are pull the image and we are inside the container. The reason why I say we are inside the container is because if you notice, the shell prompt has changed. Earlier, it used to be a little different. This is my host shell prompt. Right now, we are a root user inside the container. I'll open another terminal just to show you the list of all running containers. The reason why I cannot use it in this terminal is because I'm inside the container in this terminal. Okay, I'm zoom in. Now if I run docker ps, so now we have one container running and its status is up 35 seconds and the image is Ubuntu that we just ran. And then the container ID starts with BC2B. If we go back to the other terminal, notice the host name of this container, BC2B. So we're inside this container. Now, this is just like any Ubuntu shell. You can do pwd ls. Oops. Ls will give you a list of all files. This is just like any Ubuntu container. Now, if I exit out of this, I've exited out of the container. And now if I look at docker ps, it has exited the container as well. So that's one of the things that you need to keep in mind. If you exit out of a container, you generally will be the container will also get into an exited state. Okay. Now if I look at docker ps-a, you'll notice that the Ubuntu container is in an exited state because we exited out of the container, and it was given a random name once again, and there was no port mapping specified by us, so the ports column is empty. All right, let's look at the next thing. Docker ps, we already went over it. There's the --all flag, or to use all display all containers. And docker stop is when you want to stop a running container. For example, let me start a container in detached mode. Docker run -d. I'll start an nginx container. So this is a web server, and I'll map the port 3000 on the host to port 80 inside the container. So the nginx container is running on port 80 inside. The nginx server is running on port 80 inside the container, and I'm mapping that port to port 3000 on my host machine. So now if I run this, once again, it is not able to find the nginx image. It is pulling it. And I've also specified the -d flag, which means it will run in the background. So I'll have the shell to myself. I can also show you what happens if you don't use the -d flag. So for example, now I'll run it on a different port 3001. This is in a completely different terminal, by the way. Port 3001 on my host to port 80 inside the container. Once again, the nginx image. I'll specify name for this container. Name nginx foreground. So we're not running this in the background. So the name of the container will be nginx foreground. If I go back to this terminal, okay, now we have the prompt back. I'll clear this. I'm not sure if you can see the bottom. So now if I run docker ps, there's one container because it is it is running in a detached mode, and it is mapping the port 3000 on the local host to port 80 inside the container. So that's where the port mapping is specified under the ports column. The output is a little jacked because I've zoomed in, but yeah. Now if I run it without the -d flag, let's see what happens. Right. So now the Nginx server is actually running. Let me go back to the other one and then show you Docker PS. So there are two containers running right now. There's Nginx foreground running as well. But if I go to the other terminal, you'll notice that I don't have the terminal back. It's still waiting, following the logs of that Nginx container. So that's the reason you want to run servers in the background so that you have the container, so you have the terminal with you. Now, let's say I want the terminal back and then I use Control C and close, exit out of that. So now if I do Docker PS, that foreground container is no longer running. So that's the reason you need to run it as in a detached mode. So that's just some context about detached mode. And now Docker stop. We have one container running. So I'll stop it using Docker stop. I'll copy the container ID, and you can either specify the container name or the container ID. So I've stopped it using Docker stop. Now if I run Docker PS, there is no containers or anything because I stopped it using Docker PS. Sorry, Docker stop. Now if I run Docker PS -a, there are two containers that are in the exited state. One of them was because I killed it using Control C because it was running in the foreground, and the other one I killed it using or stopped it using Docker stop. All right, so that's about Docker stop. And the next one is Docker RM. So now these containers are in stop state. I can go ahead and remove them, Docker RM, and then the container ID or the container name once again, and you can specify multiple containers using Docker RM. It'll go ahead and remove all of them. So it will print out the IDs of the container it removed. Now Docker -a. Those Nginx containers are no longer present because I removed them using Docker RM. Okay, so let me see. Are there any questions so far? No. Okay, I'll go ahead with the Docker file where you can build your own custom image. So this is used to define how an image should be built. So it has a set of instructions. I went over this, and then it is usually named Dockerfile. But for the matter of fact, it can be named anything. And there are no file extensions for this. But if you add .txt as well, it should be fine. And when you're specifying using Docker build, you'll need to specify the file name. But the best practice is to name it as Dockerfile so that you don't have to explicitly specify the file name. All right, some keywords. So these are the instructions that you provide to Docker. So the first one is, or the most important one over here is the from instruction. So this specifies the base image on top of which the new image should be built. So like I mentioned, each image should have an existing base image on top of which our image is built. So if you have a node-based application, the base image will be Node. If you have a Python-based application, the base image will be Python. There are a set of standard images that are available on Docker Hub. They are under the library / context. So there are a set of standard ones that are available. You can also specify the version of the node or the Python image that you want using the tags. So you'll always need a base image that you would specify using the from keyword. And the next one is work dir. So this is not really a mandatory instruction. This specifies the working directory or the context for the image that we're building. So when you're building an image, you would run a set of commands, that is maybe npm install or installing any system package or anything for that matter. You'd be running a set of commands. All of those commands will be executed in this work dir directory that you specify. If you don't specify this, it will run in the root of the machine. So all containers are usually Linux-based containers. So it will follow the Linux file system. and you can specify the working directory that we want using the work dir instruction. And the arg instruction is used to specify the build arguments. So when you're building an image, you can specify the certain arguments during the runtime. That is, you don't have to specify all arguments in the Docker file. You can specify certain values while building an image. So all those values that you would be specifying, you need to specify that in the Docker file using the arg instruction. Probably makes better sense when I look at an example of a Docker file. But I'll just go over the keywords first before looking at an example of a Docker file. And in the expose keyword instruction is used to expose a certain port outside the container. So we went through the Nginx container that is also one of the standard containers that are images that are available. So it has a server running on port 80. So that port 80 was exposed inside that container. So using the expose instruction. And the next one is the run instruction. It is used to run certain Linux commands inside the image. So for building an image, we'll have a certain set of commands that we'll need to execute. For example, npm install or pip install to install the dependencies. Whatever package manager is being used, we'll need to use the run instruction to specify what command we need to execute. Not just installing dependencies, it can be updating system packages or anything for that matter. Any Linux command can be run using the run instruction. And the copy instruction is used to copy contents from the host to the image. So this is where you would copy the source code from your host into the image. So that's how the image gets the actual source code. There are other ways to get the source code as well. For example, you can maybe get it from GitHub, or you can clone it inside the image, or maybe you can download it using curl. But the general way that we do it is using copy command. You copy the files from the host into the image. There's a similar add command as well, but I will not go over that. And then try just to keep things simple and then introductory. There's the cmd command next. This specifies the command to be executed once the image is started. So if you go back to the terminal here, if you notice, there is the command column over here. So this command is executed whenever a container is brought up. So that is specified using the cmd instruction in the Docker file. So this Ubuntu image has a cmd of bash, and this hello world image has a cmd of /hello. So that's how we would specify the command using the cmd command. Right, I hope this was clear. And the next part is where we Dockerize an actual Flask application. So I'll go ahead and copy this. This step is to get the source code. If you're not familiar with Git, I'm just cloning the Git repository using git clone and then the path to the repository. I'll go to my terminal, create a temporary file for this. I'm just creating a temporary directory so that I can run it. Right, so now that with that out of the way, I'll go ahead and clone the repository using git clone. And now I'll get into the repository or the directory. That was the next step. And then let's look at the Docker file. Cat. So this is the Docker file that we defined for this Flask application. So it's a very simple Flask application that has a server running on port 5000. It doesn't do anything. It doesn't do much. It just has a single page HTML output. All right. So for the first instruction that we have here is from Python : and then the tag. The tag that we're specifying is 3.7 -slim. So the reason why I'm specifying -slim is this is one of the tag that is available with the Python image. It is generally a good practice to use smaller base image so that the image is smaller in size. So that slim is one of the tags that is associated with the image that is smaller in size. So just one best practice to keep in mind. So I'm using the Python base image. If I don't specify the tag, it will obviously use the latest tag. And I'm setting the working directory with workdir and workshop as the working directory. This is not really mandatory, and it can be anything. The working directory can be named anything. If this directory does not already exist inside the image, Docker will go ahead and create that directory. And I'm exposing the port 5000. So the server runs on port 5000. If you look at the bottom, there is I'm running the server using Unicorn and then binding the port 5000. That's the reason I am exposing the port 5000 outside the image or the container. And you can also specify environment variables using the env instruction in the Docker file. So this application requires an environment variable of name, and I'm setting it to Docker. This can be any value for that matter, but it's generally not really good practice to specify environment variables inside the Docker file, because environment variables are generally secrets. So they need to be provided you during the runtime. That is, while you're running the container, you can specify, or while building the container, you can specify using the -e flag. The environment variables can be specified that way. Once again, it takes a key value pair, that is, name is the key and Docker is the value. And we're first copying the requirements.txt to the current directory. Dot indicates the current directory, that is the workshop directory, since we specified that as the working directory. And we're copying the requirements.txt first, and then the requirements.txt contains the list of all dependencies used by this application. So if I show you that as well, so it just is using Flask and Unicorn. And once I copy that requirements.txt, I'm running pip install using that requirements.txt. And the next step is to copy everything, that is, copy everything from the current directory into the current directory of the image. So that's what copy dot dot means. But you can copy it anywhere, copy anything from anywhere using the copy instruction. First step is the source, and the next part is the destination. So both the source and destination over here is dot. And the final thing here is we're using CMD to run our actual server. We're specifying Unicorn and then binding the port 5000. And then app is how you would run the Flask application using Unicorn. So this entire thing is our command. So if you do Docker run for this image, this is the command that would be executed. All right, so now let's go ahead and build this. So we'll clear this first. So it's on top. So now Docker build, and we specify the tag of the image using -t, or tag in the sense here it can be the complete name of the image. I'll specify this as Docker workshop, and then specify a tag of 1.0 or 0.1. It can be anything. It's the version of the application. It can be anything, any versioning system that you follow. And the next step is to specify the context. The reason why this context is important is because if you look at the Docker file, it is copying from dot. That is, it's copying from the current directory where the context is present. And I'm specifying the context as the current directory as well. I know this might be a little confusing when I'm using dot everywhere, but the current directory is the context, and we're copying the source code from the current directory. So that's what both of these dots mean. Okay, and now I'll hit enter. So it is building the image. So each image contains multiple layers, right? So each instruction that we have in this Docker file is a new layer. And the goal or the best practice is to minimize the number of layers. And each time you make change to the image or the Docker file, it only builds from the point where it was last changed. So it caches the other layers. So that's one of the cool or interesting things about Docker. So if you notice, it is running multiple steps. First step is to get the base image and then set the working directory, exposing that port, setting the environment variable. Okay, there is some issue with the networking in my Linux machine. That's the reason it is not able to install the pip dependencies, but I'll have to fix this sometime soon. And since Play with Docker is also not available, I'll have to orally go through how you would run the Flask application. So we issued the Docker build command to build the actual image. So you specify the image name using -t, and then the context, that is the current directory dot, and you'd run the image using Docker run and in a detached mode, and map the port 80 on the host to port 5000 on the inside the container, because that's where the Flask application is running. and specify the name of the image. Since in this example, we mentioned it as Flask while running the container, we're specifying it as Flask as well. So this will bring up the container in the background since we're using -d. All right. So this was about it. Sorry, the Docker build did not work because of some networking issues in my machine. But if you're following along, or if you're watching this later, go ahead and give it a try. Either on play with Docker, that should work. And yeah, that's about it. There are actually a lot of other things that you can do with Docker, but it's just the fundamentals that I've covered. There is, Docker login to log into certain registry, um, Docker networks, Docker volumes. So each container, one thing to note about each container is that it is ephemeral. That is, once the container dies, any data that was inside the container is gone. If you want to persist that data, you'll need to use Docker volumes. And Docker networking, if you want multiple containers talking to each other, you can define Docker networks. All of that is a little advanced, and you can orchestrate multiple containers. I mentioned earlier, you can orchestrate multiple containers using Docker Compose, Docker Swarm, or Kubernetes. Docker Compose being the most simple one. And a really interesting use case of using Docker as a developer is to use Docker to run databases. For example, you want a MySQL database, and you can quickly spin up a MySQL database using Docker run -d, and then I'll map the port 3306 on my host, or 3306 on the container, because that's where MySQL runs. And next, specify the MySQL image, and then tag 5.7. And you can also specify the environment variables, that is MySQL root password. So this, whatever value you specify for this environment variable, will be the root password for that MySQL instance. So you can quickly spin up databases, not just MySQL, any database, for Postgres, any of the database using Docker. So that's one of the really interesting use cases for Docker. So you want to use a database locally and don't want to install the complete database, you can run a container of it. Right. While this runs, let's go to Q&A. So if there are any questions, feel free to let me know now in the chat, or there are other ways you can reach out to me as well. Right, so now we have the MySQL container running. So if I do Docker PS, there we go. We have the MySQL container running with the port 3306 mapped on the host. Right. So if there are no questions, I'll go to the final slide. Feel free to connect with me on Twitter. It's Avinash_UKR. If you have any questions, ask it over there. I'm also on Discord. It's Avinash Upadhyaya 4664. Yeah, that is the ID. So I'm on Discord as well. Or you'll generally be able to find me on LinkedIn or most social media. But I prefer on Twitter or Discord. That's the easiest way to reach out to me if you have any questions on Docker. If there's anything that was not clear, you want me to explain it, I'm happy to go over it once again. Yeah, thank you. Thank you for watching.
Thank you so much for hosting this. And just one quick confirmation, are you good with having us leave this on YouTube as a stream that everyone else can watch again?
Sure, definitely.
Yeah, thank you so much for your time again.
Thank
And
you.
if that's all, then yeah, we're going to end it here.
Thank you. Thank you for having me.